Get ready for a cosmic disaster on a scale never seen before. Betelgeuse, the red supergiant, is sending terrifying signals across space. Astronomers have discovered something profound about this huge object using the James Webb Space Telescope. Brian Cox has issued a very serious warning. The question that keeps coming up is, are we about to witness a supernova explosion so big that it will change the night sky forever? In the vastness of the universe, stars are born, live, and die in astonishing ways. Recently, one star has captured the attention and concern of both astronomers and the general public. It is Betelgeuse, a red supergiant star that stands out in the cosmic constellation of Orion. A large and very old star, its reddish color and changing brightness have long been fascinating. But recently, events have made people even more interested in this cosmic giant. As we learn more about Betelgeuse, we are on the verge of a major event in its history. But what could these changes in Betelgeuse mean? Are we seeing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant, 900 times larger than our Sun, something difficult for humans to comprehend. Imagine a star so large that if it were to replace our Sun, its surface would reach beyond the orbit of Mars and envelop Mercury, Venus, Earth, and Mars. This enormous size not only shows how impressive Betelgeuse physically is, but also at what stage of its life cycle it is right now as a red supergiant. Betelgeuse is nearing the end of its life, expanding and cooling in this phase that comes after converting hydrogen to helium in its core. However, the star is believed to be between 8 and 8.5 million years old. It's been changing dramatically over millions of years to become the red giant we see today. It is now in its final stage as a red supergiant. Supergiant stars like Betelgeuse undergo significant changes throughout their lives due to the constant pressures of nuclear fusion and gravity. What makes this stage of Betelgeuse unique is its reddish color. Its red hue is due to the fact that its surface is cooler than the other stars like our Sun. While the surface of the Sun has a temperature of about 5,500 Kelvin, the surface of Betelgeuse is about 300,500 Kelvin. Because of this lower temperature, Betelgeuse emits light at a wavelength that make it appear red. But this color is not just an appearance, it tells us something about the physical state of the star and the process occurring in its huge gaseous volume. The color of Betelgeuse has changed over time. During the Roman and Chinese eras, Betelgeuse was said to be yellowed about 2,000 years ago. In the 9th century, Arab astronomers were the first to claim that it was red. This change in color throughout human and scientific history has also shown how the star has evolved over time. Another interesting thing about Betelgeuse is that its brightness varies over time. It is a variable star, which means that its brightness rises and falls regularly. This variation has fascinated scientists and sky watchers for hundreds of years. Betelgeuse goes through a brightness cycle of 400 days and a longer cycle lasting 5 years. As early as 1836, Sir John Herschel wrote about these cycles, and Aboriginal stories may go back even further. However, what really makes Betelgeuse mysterious is not only how its brightness changes, but also how irregular it can be. Unlike many stars that dim and brighten in predictable ways, Betelgeuse sometimes deviates from this pattern, suggesting complicated and less understood processes with its enormous structure. Recently, astronomers and stargazers around the world were surprised to see Betelgeuse's appearance change dramatically and unexpectedly. This is known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, which is one of the brightest stars in the night sky and a prominent feature of the constellation Orion, began to dim in a mysterious way. The star was fading at a rate of 0.01 magnitude per day on average. By February 2020, Betelgeuse was at its faintest. Normally visible to the naked eye, even in places with lots of light pollution, it had become much fainter, and onlookers could tell the difference. However, the paradox of time complicates observing Betelgeuse, as it takes a long time for the star's light to reach us. When we look at Betelgeuse, we see it as it was almost 654 years ago, because it is about 654 light years away. This time lag makes it difficult to predict and monitor rapid changes in its behavior. The Betelgeuse dimming event was a reminder of how complicated it is to observe the night sky in real time, and how little we know about this big, strange world of space and time. Andrea Dupree, Deputy Director of the Harvard Smithsonian Center for Astrophysicists, and her team took a close look at Betelgeuse's dramatic events as part of a 3-year study to track changes in the star's outer atmosphere using Hubble. These observations provided new insights into how a variable star, like Betelgeuse, works. Variable stars regularly expand and contract, causing changes in their brightness. The researchers were able to observe the star's surface layers, heated in part by swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Studies of Hubble's spectra taken at different times in 2019 and 2020 helped determine how fast things were moving in Betelgeuse's upper atmosphere. They found that material was moving from the star's surface into its atmosphere at about 200,000 miles per hour, eventually reaching millions of miles away from Betelgeuse. Now, this movement of material contributed to the formation of a dust cloud that made the star appear less bright for 3 months. Dupree and his team thought that about twice as much material from Betelgeuse's southern hemisphere had been ejected. This mass loss was remarkable because it occurred at a much faster rate than expected. The astronomers wondered whether this event might be a sign of an upcoming supernova explosion, given how large the mass release was and how faint the star became. At 654 light-years from Earth, Betelgeuse's behavior remains a mystery. Such an explosion would be visible from Earth and would give people a rare chance to see a supernova up close. But the question remains, is this a sign that a supernova is about to occur? Or is it simply a one-time event in the long and complicated life of Betelgeuse? Several theories have been proposed to explain this rapid change. Are you prepared for what is about to happen? Betelgeuse, a huge red supergiant, the closest to Earth, has experienced a remarkable dimming in recent years, generating mixed emotions around the world. Some speculate that this phenomenon could be a precursor to a supernova, a cataclysmic event that causes concern among scientists and the general public. Betelgeuse, a prominent figure in the constellation Orion, has gained some of its brightness after dimming, but appears to be transitioning to a less active phase. Scientists are concerned about the possible outcome of Betelgeuse's life and whether its eventual explosion could affect Earth. Orion, one of the most recognizable constellations, is known for its 2 main stars, Rigel and Betelgeuse. Betelgeuse, also called Alpha Orionis, it is the brightest and largest star in Orion. Data collected by NASA's Hubble Space Telescope and other observatories indicate that Betelgeuse underwent a massive mass ejection in 2019, a behavior never before observed in a star of its type. While coronal mass ejections are common in our Sun, this event on Betelgeuse is unique and arouses great interest among astronomers. Betelgeuse corona, however, surprised scientists by ejecting an amount of mass of 400 billion times greater than the average coronal mass ejection, CME. This cloud of hot gas released by the star temporarily covered some of its light, leading to the unusual dimming observed. Although some estimates place Betelgeuse farther away, it could be as close as 724 light-years from Earth. Determining the distances of red supergiant stars like Betelgeuse remains a challenge for astronomy because of its great distance and peculiar characteristics. Betelgeuse is one of the brightest stars in the night sky, being about 100,000 times more luminous than the Sun. However, this intense luminosity comes at a price, as Betelgeuse's immense energy rapidly depletes its fuel, hastening the end of its life. Eventually, the star will run out of fuel and disintegrate under its own weight, possibly giving rise to a supernova and eventually a neutron star or even a black hole if our current theories are accurate. Does Betelgeuse pose a threat to Earth? A supernova outburst a few tenths of light years from our planet would have devastating consequences. When a supernova explodes, it can generate an amount of light equivalent to an entire galaxy, which means that even if the star is relatively close, such as Alpha Centauri, its effects could not be ignored. Since 1604, we have not yet witnessed a supernova in our own galaxy, although in 1987 one occurred in the Large Magellanic Cloud at a distance of 169,000 light years, with remarkable effects, although it did not pose a direct risk to us. The danger zone around a typical supernova is an intriguing concept that could have serious implications if such an explosion were to occur in our vicinity. However, it is important to keep in mind that, in cosmic terms, nearby supernovae are relatively small events compared to gamma-ray bursts, which are of a completely different scale and much more powerful. Supernovae are bad news. They have the power to destroy biospheres and blanket the world with lethal radiation. A planet's ozone layer can be destroyed by a particular type of supernova years after the explosion, according to a recent study that adds a new potential danger. Giant stars can briefly reach some of the highest luminosities in the universe when they explode in a large explosion known as supernovae. The brightness of hundreds of billions of stars combined can be eclipsed by a single supernova. Will the Earth be destroyed by a Betelgeuse supernova? The star will be the second brightest object in our sky after the Sun when the supernova occurs, despite being away from us. Betelgeuse, which shines brighter than a full moon, will be visible during the day. It will be so dazzling for a few weeks at the peak of the explosion that shadows will even be cast in pitch darkness. Despite its terrifying brilliance, the visible light emission from a supernova constitutes only a small amount of its total energy output. Furthermore, although exposure to high levels of visible light can result in blindness, it generally does not have many other detrimental impacts. The high energy radiation associated with the supernova, which generally takes the form of X-rays and gamma rays, is more of a concern. This high energy radiation has the ability to catalyze the removal of oxygen from the ozone layer that protects the Earth. Without the ozone layer, life on Earth's surface would be exposed to the full force of the sun's ultraviolet radiation, which could result in an extinction event in the first few seconds of a supernova. After the initial outburst of radiation, a greater threat emerges over time. Eventually, hundreds or millions of years later, cosmic rays, which are subatomic particles accelerated to nearby the speed of light, emerge from the maelstrom. They can also shatter ozone layers and blanket the planet's surface with deadly radiation, in addition to carrying with them a considerable part of the total energy of the supernova. Such events could have occurred in the past. Significant levels of iron-60, a radioactive isotope of iron created in the supernovae, are found in cores of the seafloor and lunar regolith. According to the analysis, iron-60 is a sign that the Earth was recently hit by a supernova ejector, possibly within the last few million years. Astronomers have previously determined that we are fairly certain there are no close supernova candidates that could endanger life on Earth based on the dangers posed by gamma rays and cosmic rays. But astronomers have discovered an additional possible risk. A specific type of supernova has the potential to emit deadly radiation that is additional, long-range, and dangerous to worlds like Earth. When a star nearing the end of its life is surrounded by a substantial disk of material, a specific kind of supernova arises. A shockwave is generated after the initial explosion of the supernova and strikes that disk. This shockwave causes the disk to become extremely hot, which in turn leads to the disk to generate a large amount of X-ray radiation. This radiation has a high energy density and a very long travel range. The brightest X-ray supernovae can overload a planet's ozone layer, depleting it by as much as 50%, which is more than enough to trigger an extinction event within a staggering 150 light-years radius. Such supernovae would deliver a lethal blow. A fragile planet would be bombarded by X-ray months and years after the initial airburst. Then, cosmic rays would arrive hundreds of thousands of years later and complete the task before the biosphere had time to recover and replace its protected shell. Fortunately, no candidate X-ray supernovae have been found to be close to Earth, but the galactic habitable zone, the area in each galaxy where life can exist, is now subject to additional constraints as a result of this research. Star formation is insufficiently high in the outermost regions of a galaxy to produce the elements needed to generate rocky planets. However, dense star centers, where stars live and die rapidly, are equally dangerous because frequent supernovae irradiate the surrounding area. According to the new research, it is likely that the inner boundary of the galactic habitable zone is located farther away from the galaxy's core than previously thought. What will Betelgeuse supernova explosion look like from Earth? Earth biospheres will be unaffected, but that doesn't guarantee that no one will notice. According to Goldberg and Bolger, Betelgeuse will shine more than 3 months after its explosion with a luminosity comparable to that half of the Moon, 9 times fainter than the full Moon. A single point would contain all its luminosity, so it would look like a very bright beacon in the sky that could be seen during the day and cast shadows at night. It will be inevitable, and everyone on the planet will be fascinated by it. The supernova would be visible to people in the sky during the day for about a year, and as the supernova remnants fades, it will be visible to the naked eye for several years. The James Webb Space Telescope has made a significant breakthrough in providing us with an unprecedented view of the universe. On this occasion, it has gone deep into the depths of the famous supernova NN 1987A. This telescope has revealed new structures that had never been seen or observed by previously telescopes. When the star exploded in 1987, it became the brightest supernova visible from the Earth in nearly 4 centuries. SN 1987A lies at a distance of about 170,000 light-years from us. Located in the Large Magellanic Cloud, a dwarf galaxy close to our own Milky Way. The new image captured by the telescope uniquely shows the structure of the center of the supernova remnant, which is shaped like a keyhole in shades of blue. Join us on this 170,000 light-year journey to the Large Magellanic Cloud to discover all the details of the core of supernova SN 1987A. The core of the supernova is composed of gas and dust ejected by the supernova explosion, and the dust is so dense that even infrared light detected by the telescope cannot pass through it, creating a dark keyhole. Inside the keyhole, we find a bright equatorial ring that forms a band around the central region and connects 2 faint hourglass-shaped arms. This equatorial ring was formed from the debris ejected tens of millions of years ago before the supernova explosion and features bright spots that emerged when the supernova shockwave impacted against it. According to the information provided by NASA, the bright spots that had been detected were formed when the shockwave generated by the supernova explosion impacted the equatorial ring of gas that the stars had ejected several tens of millions of years before its explosion. These bright spots can now be detected even outside the main ring, emitting light diffusely into their surroundings. These areas are where the collisions between the shockwave and the outer material take place. In addition, the Webb telescope has revealed additional crescent-shaped structures which had gone unnoticed in earlier observations with the Hubble Space Telescope. NASA suggests that these crescent-shaped formations are the outer layers of gas ejected during the supernova explosion. NASA, in its press release, mentioned that despite decades of studies since the initial discovery of the supernova, several mysteries remained unsolved, especially regarding the information of neutron stars that should have originated after the supernova explosion. The space agency also notes that the James Webb Space Telescope will continue to observe the supernova in the future. The James Webb Telescope has identified another dying star in the Southern Ring Nebula, which also shows intricate structures corresponding to the final stages of a star's life. This nebula is bright and lies at a distance of 22,000 light-years from Earth, making it visible with binoculars on clear summer nights in both the northern and southern hemispheres. This observation should not be confused with one of the first images captured by the James Webb Space Telescope. The international collaboration known as ESSENCE, consisting of experts from several countries with expertise in planetary nebulae and other related objects, recognize the importance of making observations over the network to obtain essential information. In particular, the Ring Nebula was identified as an ideal target because of its perfect fit in the field of view in the mid-wavelength infrared camera aboard the James Webb Space Telescope. This choice allowed the nebula to be explored at an unprecedented level of spatial detail, which in turn helped to unravel some of the mysteries surrounding planetary nebulae. Thanks to its array of infrared sensors, James Webb was able to capture images that offer exceptional spatial resolution and spectral sensitivity amid the cosmic chaos. According to the release, this means that the telescope, located at a distance of approximately 1 million miles, 1.6 million kilometers from Earth, was able to reveal previously unseen details of the nebula's intricate structure. When scientists first observed the images, they were astonished by the abundance of detail they revealed. The bright ring that gives the nebulae its name is composed of about 20,000 individual clusters of dense molecular hydrogen gases, similar to what we find on Earth. Within the Ring Nebula, a narrow band of emission containing protocyclic aromatic hydrocarbons and complex carbon molecules is found. This finding is surprising, as we did not expect to find these molecules in the Ring Nebula. Outside the bright ring, we observed particular peaks extending in opposite directions from the central star. These peaks are especially prominent in the infrared spectrum, but are not as evident in visible images captured by the Hubble Space Telescope. It is believed that these peaks may be related to molecules that have the ability to form in the darker, denser areas of the ring. In these areas, the molecules will be shielded from the intense direct radiation emitted by the hot central star. This includes a capture of infrared light, which is invisible to the human eye. The James Webb Space Telescope provided detailed information on the structure of the ring filaments, as well as the presence of approximately 10 concentric R's in the outermost regions of the nebula. These target-shaped R's were a surprise, suggesting that they formed about 280 years ago, when the central star was shedding its outer layers during the transition to a planetary nebula. This time period is unusual and no known process can explain it. Instead, the presence of these rings suggests the possible existence of a companion star in the system, orbiting at a considerable distance from the central star, similar to the distance between Pluto and our Sun. As the dying star expelled its atmosphere, the companion star may have influenced the formation of these rings. Roger Wesson of Cardiff University offered an explanation for this phenomenon, noting that no previous telescope had the sensitivity and spatial resolution capability to discover this subtle effect. Importantly, this is not the first time the James Webb Space Telescope has looked at the Ring Nebula, indicating the continuing importance of studying this intriguing phenomenon. The history of the Ring Nebula represents a symbol of human curiosity and scientific progress. From its early misinterpretations as a planetary nebula to the advanced technology of the James Webb Space Telescope, our quest to understand this phenomenon has closely followed the development of astronomy. The Ring Nebula was discovered in 1779 by astronomers Pierre Méchain and Charles Messier, who included it in their Messier catalog while attempting to track a comet through the constellation Lyra. Today, this nebula has become an emblem of astronomical archaeology. Its distinctive brightly colored ring represents the remains of a dying star on its way to becoming a white dwarf, acting as a striking reminder of our cosmic connection. In studying the Ring Nebula, we're not only observing a distant object, but we're exploring the past, present, and future of the universe itself. We may even consider that our Sun, in about 5 billion years, could give rise to a similar nebula at the end of its life, although it is unlikely that we will be around to witness it. It is important to note that the color differences in the images of the same nebula may appear strange. This is because the James Webb Telescope observes objects at infrared wavelengths, which are invisible to our eyes. The original Webb images appear black before the image processor translates them into visible light wavelengths, which highlights certain aspects of the nebula in each image. The James Webb Space Telescope, with its ability to explore everything from the deepest views of the universe to the rings of planets in our own solar system, is giving astronomers an exciting new perspective on space. The question arises, what discoveries does the future hold with the James Webb Telescope? Let us know in the comments box what discoveries you would like the James Webb Telescope to make. If you liked the video, remember to hit the like button and subscribe to the channel. And I'll see you in the next one. Thank you so much for watching.